hello and welcome to Oliveboard platform and very good evening to all of you. Hi, good evening everyone. I hope so. I'm audible clearly. Please do let me know in a comment box, please. Hi. Hi, good afternoon. Hi. I'm audible properly? Okay. Thank you everyone for confirmation. Okay, so today we have a chapter to discuss. Just a minute. Okay, so today we have a chapter for practice, that's your heat and thermodynamics. Basically in this particular chapter we need to see especially the heat part and the associated terminology which is actually related with the heat part. Then after, in a case of thermodynamics, it is basically about the mechanics behind the heat, and also we need to cover the temperature and how to convert a particular temperature into a different scales. Okay, so these are the content which we need to cover in this particular chapter, and today's session is completely based on the question part, so we will consider the related questions. Okay, if you have any issues or doubts, do let me know, please. Anyone? Okay, okay, so moving. Okay, just a minute. No, this is a tier 2. Yes, yes, but only for a tier 2 students. Any other doubts? Okay, so shall we start? Okay, starting with a very
So,
first.
shall we start?
Starting with first question. Here's your first question, and the question is: steam at 100 degrees centigrade cause more severe burn than the water at the same temperature because steam at 100 degrees centigrade cause more severe burns than the water at same temperature because. Anyone? Your option is: steam is a gas, steam provides more heat, steam is highly combustible, or steam exert more pressure. First D, steam is a gas. Okay. Anyone else? Any other inputs? No. Okay. So actually, steam at 100 degrees centigrade cause more burn. Okay. Then the water at the same temperature, because steam always carries what? So it always carry additional energy. It always carry additional energy in the form of latent heat of vaporization, right? Because we do not have any related terminology with the latent heat part, so here we can say that actually when steam condense, right, on the skin, it release the extra energy. Okay, and that is why it causing more to be transferred the body than the heat transferred by the water alone. Okay, so the correct answer is steam provide more heat, steam is highly combustible, steam exert more pressure. So here we can choose that steam provide more heat only, or steam carry a more energy. Instead of this part we can also use it. Clear? Okay, now here we got a word that is latent heat. See, now what is latent heat here? Okay, so latent heat basically steam. See, steam is water, but in which state? It is in gaseous state. To become a steam, water must absorb some energy for its phase change, right? And this particular thing is known as latent heat of vaporization. Okay? Sorry, that's okay. So ultimately we can say steam is water. Okay, this is clear, right? But in a gaseous state. Okay, now to become steam must absorb energy, right, for its phase change, and that energy is termed as latent heat of vaporization. Clear? Next, at what temperature the reading of a centigrade and Fahrenheit thermometer is the same? Sorry. 40, 212 minus 40, 100. 2 degree centigrade minus 40. Acha. Okay. Okay. So actually formula is here we need to see Fahrenheit. That means F is equals to 9 by 5 C. Okay. Plus 32. Now you can also solve it. So here you can take X is equals to 9 by 5 plus 32. Subtract this 9 by 5 from both sides. Okay. So X minus 9 by 5 is equals to 34. Now simplify the left side of this part. So minus 4 by 5 is in X is equals to 32, or X is equals to minus 42 if you are taking this value 32 divided by 54. Okay, so the correct answer of this question is minus C is your right answer. Actually this formula will help you a lot, so keep in mind this particular changing formula. Can anyone tell me what is the changing formula? If you want to change degree Celsius into Fahrenheit, Fahrenheit into Kelvin or somewhat. Anyone? Anyone? Formula. What is the formula for all type of temperature? I'm telling you. See, the formula is C by 5 is equals to F minus 32 upon 9 is equals to R upon 5. Okay, this is a formula which you can use for each and every changes. Okay, so please note it down. Next question. Now your next question is, transfer of heat by convection can take place in solid and liquid, solid and vacuum, gas and liquid, vacuum and gases. Convection, there's a mode of transfer of heat: convection, conduction, radiation. Okay. C, gases and liquid. Okay, anyone else? Convection. Okay, see, in a case of, first of all, let's consider what is convection, what is conduction and something. First of all, let's consider this convection. See, now what is convection here? So actually convection is just a mode of heat transfer. Okay, what is this? So this is just a mode of heat transfer. First of all, this will also help you to revise your content, right? Transfer by actual motion of matter. Now what is actual motion of matter is, for example, you put a beaker full of water, right, on a gas. After some time you will see a droplet, right, a drops of water kind of thing. So there's a globule of water, and once this globule, whatever the globule is receiving a heat more, start moving upward, right? And this because this is cold and heavy in its weight, so that is why it is moving or achieving that particular position. So this is what our actual motion, right, actual motion of water, and this is only possible in anyone, solid and liquid, and you answered gases and liquid. That's correct. Okay, correct answer is option number C. If it is conduction, so conduction is only possible in solid, conduction in solid only, solid. This is what conduction. Okay, clear? Next. Now your next question is correct. Convection can be natural or forced or induced. In a natural convection, gravity is also a perfect example, we can say. Okay, moving to the next question. A liquid remains hot or cold for a long time in thermos because there is no loss or gain of heat by. Anyway, your options are conduction, convection and radiation, both A and B, and none of these. For C, both A and B. Okay, that means conduction, convection, radiation, all. Huh? See, thermos flask, right? So this is a thermos flask, and this thermos flask is consist of a double layer, right? It is always consist with a double walled glass vessel, right, resting on a cork and inside a metal or plastic area. It is always coated with silver sometime. Okay, thermos flask was invented by James Dewar, just telling you, James Dewar in 1892, and because it has a double glass vessel, vacuum prevent heat loss by the conduction. But again, there are, everything is possible in a case of thermos flask. So the correct answer is option number C. Okay, next. The body temperature of a healthy man is body temperature of a healthy man. uh, 37 degrees Celsius, 37 Fahrenheit, no, only 37 degrees Celsius. Okay, if it is Fahrenheit, 98.6 Fahrenheit, right? 98.6 Fahrenheit, 37 degree Celsius will be your right answer for this question. So this is the part. Next question. The normal temperature of a human body is 98.4 Fahrenheit. It is equivalent temperature in degrees Celsius is. Please apply a formula, everyone. Do not just jump onto the question answer. Sorry. Please apply a formula if you can. B. 30. Okay. 36.89. Okay. Correct answer is option number B. That's your 36.89 degrees centigrade. Okay. So correct answer is this, and also you can use that formula, that is C is equals to 5 by 9 F minus 32. This is also a formula. Okay, next. Which one of the following scale of temperature does not have a negative value? Because that particular scale is an absolute temperature. Zero Kelvin represent what? 0 Kelvin represent absolute zero. Okay, so the correct answer is Kelvin. Option number C, right? Correct answer is C is your right answer. That's a Kelvin part is a correct answer. Okay, so Kelvin, here we can also call it that Kelvin scale is an absolute temperature scale starting at an absolute zero, right? Where all molecular motion what? Always cease. Okay. Absolute zero is what? So absolute zero is always defined as a 0 Kelvin on the Kelvin scale, right? Which is equivalent to minus 273.15 degrees Celsius on a Celsius scale, right? Since the Kelvin scale start from absolute zero, it does not have a negative value here. Next. The value of 40 degrees Celsius in Fahrenheit scale is 40 degrees Celsius in Fahrenheit. F is equals to C into 9 by 5 plus 32, right? F is equals to C into 9 by 5 plus 32. Acha, okay. C is 40, sorry. 40 plus 32, okay. Fahrenheit 8A104, okay. Now you can calculate it. F take out here and 72 plus 32. 72 plus 32, 4 plus 104 degrees centigrade. Okay, so the correct answer is option number A, right? Next. The value after in Fahrenheit scale is answers please. हेलो 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 चंदन, हाय, कैसे हैं आप? करिए आंसर. The value after in Fahrenheit scale is question. I think value is missing here. Something is missing in this question. Kindly skip this question, please. Value is a skip. Okay, your next question is a glass bottle containing water tightly corked break when it keep in freezer because Okay. Water shrink on freezing. The volume of water decrease. The volume of water increase. Glass is a back conductor of heat. Water always expand when it turns into ice. Okay, so when the water cools below 4 degrees centigrade, it begins to expand, right? And because the bottle is completely filled and sealed, the expansion or whatever the expanding ice exert pressure, right? Pressure against the glass bottle or against the glass. So obviously the volume of water increase on freezing, and ultimately it causing a break, right? And the water burst. Next. When a piece of ice floating in a glass of water melt, the level of water will. When a piece of ice floating in a glass of water melt, the level of water will. Remain same. Rise. Density concept. It remains same. Remains same. This is because ice displace. See why? Because ice displays an amount of water, right? Amount of water which is equal to its volume, and when it whenever it is melt, right? And it occupies the same volume in a water. That is why it remains same. So the correct answer of this question is option number C. Okay, density is mass per unit volume is called density. So the concept is density part. Okay, next. Pendulum clock becomes slow in summer because pendulum clock. Thermal expansion. See, most of the substance always expand on heating and contract on cooling. Okay? So expand on heating and contract on cooling. Okay, whenever there's a change in the temperature of the body, it always cause its dimension. Okay, and the increase in the dimension of a body due to the increase in its temperature. So in a summer, temperature rise, so the length of the pendulum increase. The weight of the weight will be same. Okay, so it will be a increase in the length. This is what a thermal expansion. Next question. Your next question is here, and the question is C. Which of the following statements are true regarding heat? Heat is a form of energy. Heat can be reflected by mirror. Heat is an electromagnetic radiation. Heat cannot pass through vacuum. Select the correct answer from the code. Regarding a heat. Heat is a form of energy. This is true. Yes, this is absolutely right. Then after, your heat can be reflected by mirror. Absolutely right, this is also correct, right? Then after, heat as an electromagnetic radiation, correct? Okay. Heat cannot pass through a vacuum. This was wrong. Okay, so only first, second and third travel in a vacuum, correct? So heat cannot, so it can, right? So obviously this is wrong, otherwise your statement number first, second, third is right here. Heat is basically a form of energy that is flow from one body to the another body due to the difference in the temperature. For example, you put a hot cup of tea at your table or on your bed. After some time, you will see the surface where you put it, that cup, is also hot, right? Or it is also warm, because there was a temperature difference. So due to that temperature difference, the heat flow from a higher region to the lower region, and this is what a heat. Okay, next correct answer, 1 2 3. Okay, your next question is here, and the question is, energy travel from sun to the earth through. Sorry. Again, it is a mode of transfer of heat that needs no medium, and the correct answer is radiation. This is also just another mode of heat transfer that need no medium, right? And it is called what? It is called radiation, and the energy so radiated by electromagnetic waves. Keep in mind, by electromagnetic wave, right? Which is termed as a radiant energy, which is called as a radiant energy. Okay, conduction, in a case of conduction and convection, always requires some material as a transport medium, right? But this mode of heat transfer cannot operate between bodies separated by a distance in a vacuum. Okay, so the correct answer is option number C is your right answer. Next, okay, your next question is here, and the question is, what is, okay, and the question is, what is absolute zero temperature? What is absolute zero temperature? The starting point of any temperature scale, theoretically the lowest possible temperature, the temperature at which the vapor of any liquid substance is condensed, the temperature at which all material are in vapor form. Option B. Okay, theoretically lowest possible temperature, absolutely right, where all the molecular motion ceased, right? All the molecular motion ceased, right? And which is equal to 0 Kelvin or minus 273.15 degree Celsius. In a Fahrenheit, can you tell me? In a Fahrenheit, minus 459.67 Fahrenheit. Okay, values of absolute temperature value in a different scale. Next, when ice melt, then volume increase, volume decrease, mass increase, mass decrease. Anyone? When ice melt, its volume decrease and mass always remains same, or we can say mass stays same. There will be a no change in a case of mass. Whenever ice melt, for example, ice was putting here, right? As it melt, it always melt from a surface, lower or a bottom part. This question has been asked, right? And start moving like this, right? So volume increase, but the mass of the particular water molecule or water content will be same. Okay, next. It is more comfortable to wear white cloths in summer because they reflect all the heat falling on them, they radiate heat transferred from the body, they absorb perspiration, they are soothing to the eye. Or we can say why light colored clothes are preferred in summer. Reflect, light color are poor absorber. Okay, so reflect all. Okay, okay. Or we can say light color or white color poor absorber of light, right? Or we can say that they reflect all the light, right? Reflect heat, which help our body to keep cool. Correct answer is A. Next. Radiation is the process in which heat is transmitted from of the place to another. Correct. Radiation is a process. Direct without any medium. Okay. Actual movement of the vibrating particle. This is an example of conduction. In a conduction, for example, we have a iron rod, right? You start heating this iron rod from here, the molecule starts heat or getting heat, and as they get heat, they start vibrating, right? Once this molecule vibrate, it basically give a instant motion to the another molecule, and through this process finally the last end or whatever the end part of a particular material is also get heated. This is what conduction. Whenever there's no medium, it is termed as a radiation. Or we can say whenever there's a heat of transfer without any medium is termed as radiation. So the correct answer is option number C. Actual motion of the particle is an example of convection. Sorry. Next. On heating an object, its molecule. Just define you. Answers please. Just give me a minute. Thank you. Okay. On heating an object, its molecule, kinetic energy increase, will decrease, load will increase, weight will decrease, speed will increase, right? Or we can say kinetic energy increase, right? Correct answer is option number A. Okay. So gain energy, begin to move faster from vigorously. Next. Which scientist first melted two pieces of ice by rubbing them together? Rumford, Joule, Davy, Celsius. This experiment was done in the year 1799. actually this particular experiment demonstrated the heat is generated by friction. Heat is generated by friction. Okay, and this experiment was performed by Humphrey Davy. Correct, Humphrey Davy, right? And heat is generated by friction also. Next, correct. Which of the following is not a unit of heat? No. Heat. Okay. Joule. Correct answer. Joule. So SI unit of temperature is Kelvin. Temperature. Okay, and degree Celsius is commonly used unit of temperature. It is a common unit. Common unit. Okay, so the correct answer is C. Next, the value of 1 kilocalorie of heat is. Answers please. One kilo, that means 1000 into, see, 1 kilocalorie is equal to 1000 small calories. .2, okay. Anyone else? 4.1840 joule. 4184 joule. So here, acha, okay, they have to. Just a minute. Oh. Now, joule. See, 1 kilocalorie or 1 kilogram calorie is the quantity of heat required to raise the temperature of 1 kg of pure water at 1 degree centigrade, right? Which is equal to 1000 calories. So here we can answer 4.2 into 10 to the power 3 joule. Okay. An object absorbs maximum heat when it is black and rough. Okay, correct. Black and rough or black and shiny? An object absorbs maximum heat when it is black and rough, black and shiny. Rough, right. Correct answer is option number A. No. Rough surface. Dull or rough surface absorb heat better than a shiny or a smooth. Okay, so the correct answer is option number A. It gives relief to run a fan in summer. Fan provide cool air, our sweat to evaporate faster, much heat is released from our body, or none of these. Wherever, because the fan moving air, right? So moving air increase the what? Evaporation, right? Evaporation of sweat from your skin. So here we can say that much heat is released from our body. Correct answer C. Oh, sweat evaporate faster भी है इसमें. ठीक है, sorry. Correct answer option number B. Because of the question. This is appropriate because air in motion and thereby increasing the evaporation of the sweat. It increase. Okay, next. At which temperature water starts to boil on mountain? At altitude, atmospheric pressure is low, is lower. So it is no, not same. Please keep in mind at higher altitude there is a less air, right, pushing down, so the pressure is low. For example, if you are a higher altitude of around 75 feet, right, so your boiling point of a water will around reach to 92.4 degrees centigrade only. This is not minus, this is just a sign. Okay, so water boils at a lower, here we can say none of these. Oh, all options are same here actually. Okay, none of these is the right. Otherwise, please keep in mind the concept. Keep in mind. Okay, so force per unit area is called pressure, and as we go on a higher altitude, the atmospheric pressure decrease. Okay. Which one of the following has maximum heat capacity? A. Gold. Now, specific heat, maximum heat is basically amount of heat 1 gram of material has to absorb or lose. Correct answer is water. Option number B. Helium minimum. Water has the maximum heat capacity among common substance, I guess. Next. How many Celsius is equal to 300 Kelvin? Anyone? 27 degrees Celsius. Okay. C is equals to K minus 273. K value is 300 minus 273. C is equals to 27 Celsius. Okay. Correct answer is option number B. Right. Next question. Okay. Okay, so here we have completed this session, everyone, with some questions of your heat and thermodynamics. If you have any doubt from any concept of heat and thermodynamics or any thermal properties of matter, please do let me know. The major points we need to carry in this particular chapter: the mode of transfer, that is your conduction, convection and radiation. Then after, temperature changing part, aluminum, Celsius to Fahrenheit, Fahrenheit to Kelvin, and so on. Then after, your thermal expansion is here. Please tell me. Then after, your change of state, latent heat also. These are the main concept part from this question, from this chapter actually. Sagar, please put your doubt. Ice melt, water level same, but why volume decrease? See, so volume of water, see here, whenever a piece of ice, okay, floating in a container of water melt, the water level remains same. Actually this is your question, why it remains same, right? So actually volume of water displaced by floating ice. For example, you put that ice here, right? Now it displaces the amount of water, and then after it starts floating here. As it starts melting, it is also equally, it is equal to its weight, it is melting, right? But the point is, so basically here the volume of water displaced by the floating ice is equal to the volume of melt ice, okay, and it turns into a liquid part. Still clear or not? See, for example, let's see properties of liquid. Just a minute. Let's see properties of liquid. Okay, for example, in a case of liquid, the molecules are little bit far away, right? In a case of liquid, the shape is always same, sorry, different, right? For example, you have a water and you put that water into this glass. That particular water will take a shape of this glass. If you are transferring this water into a bowl, it will take a shape of bowl, but again the volume remains same, because whatever the molecule of the water in it will remain same. Okay. Okay, so here we have completed this session, everyone. We'll meet you on a Monday with a new topic and new question. Okay, in a convection, lower particle rise above. So why we say particles don't move? Low convection, lower particles rise above, not rise above. In a convection rise above. So why we say particles do? No, the convection is all about the actual motion of the of the particles. The definition of convection is the actual motion. Wait, I'll show you. I have a slides. Wait. Can you see my screen now? In a question? Okay, in that case, let me check. Just a minute. Can you please tell me the question number? अरे तो वो है okay, Sagar, let me check the question 5 question back. Just a minute. My file got skipped actually. Wait. Just a minute. Oh God, क्यों नहीं जा रहा भाई? Five question back. Tell me, question number at least. This was a question. Please tell me exact question number, once you see your question. Yes, ma'am. Which question, yaar? In option, you wrote convection. Okay. Acha, okay. Actual motion. Without the actual motion is conduction. Okay, I write it wrong. Wait. By the actual movement of the vibrating particles. Sorry. See, I'm telling you again. Conduction is actually due to whenever there's a heat of transfer because of vibration of particles, right? The particles will remain same at their position and start moving, right? As it is, for example, I'm a particle, I'm moving or I'm vibrating at my position, definitely I'm disturbing the another particle, right? So through this process the heat transfer is termed as conduction. Then after, in a case of convection, there's an actual motion of particle. You will see once the hot particle start basically it is the temperature increase, it starts move forward or upward, and then after the upper particle start moving downward. Okay. Okay, thank you so much and very sorry for this. Okay, thank you everyone. We'll meet you in the next class. Bye bye, take care.